Those who are online are able to hear me. Those who are online are able to hear me. Am I audible?
Yes, sir.
So today we are going to discuss the last topic of the first volume. Not for the chapter, for the first volume, right?
Sir, we're not able to hear you properly.
Okay, I'll come. So am I audible now?
Yes, sir, better.
Okay. So listen, we discussed two chapters, like what were they? Matrices and determinant. They are actually combined together. You cannot read them as two separate chapters, right? So what did we deal in matrices? Let's again recollect. We saw how data can be represented in the form of rows and columns. So if you see matrices, main application is about arrangement of data and operations of data. Is that right? So when you had different kinds of matrices, you had matrices of different orders, right? Where the rows and columns will be different. Then you perform different kind of arithmetic operations between them. What were the operations we perform? Addition, subtraction, and multiplication. There is no concept of division of matrices. You cannot divide one matrix with another. Like how you cannot divide one way with another. You cannot do the same with the matrices as well, right? So after that, what did we see? We saw that there is something called as inverse of the matrix that exists. So what is the inverse of the matrix? The inverse of the matrix will exist for what kind of a matrix in the first place? For a square matrix. So for a square matrix, if I'm able to have another matrix B, so that the square matrix multiplied with B should give you one or other. One is a number. When you multiply a matrix with a matrix, how will you get a number? You get another matrix. You call it as identity matrix. Right? So when you get an identity matrix, then you can say B is the inverse of A and A is the inverse of B. Right? I told you in the previous chapter that there are two ways of finding it. One is using elementary row or column transformation, which is deleted. And I told you very clearly, even if it is deleted, it's good for us because it's a waste of time. There is no point in learning it. Okay. So there is another way that we have discussed in this chapter, which is, we saw it in the previous class, using adjoint. Right? Is that right? So how do you calculate the inverse using adjoint? A inverse is equal to adjoint of A divided by determinant of A. But for inverse to exist, what should be the first condition that should be verified? The square matrix is fine. Using adjoint method, if you want to find the inverse of the matrix, the first thing, even before you find the adjoint, what are you supposed to find? Yesterday I told you, find the determinant. If the determinant is equal to 0, forget about inverse. Okay, inverse does not exist. So if the determinant is 0, what is the name of that matrix I told yesterday? Starts with letter S. It's called singular matrix, right? So for a determinant, for the inverse to exist, the matrix should be a non-singular matrix. Is that clear? And the most important of all is, why are we learning determinants? This I told you in the beginning of this chapter. Why are we even learning matrices? Yesterday, while concluding also I told you. Correct? You'll have to join me correct as well. We are mainly dealing them to solve simultaneous linear equations. So what do you mean by simultaneous linear equations? Sorry? So you know what are linear equations, right? So linear equations are those equations where the variables have the highest power to be 1. So if you ask me, determinants can be used to solve quadratic equations? No. Cubic equations? No. It is only used to solve linear equations and two variables. Okay. And for that, what we are going to do is, we are going to see, so as a part of the conclusion of the whole story of matrices and determinants, we are going to see a combined application of them. So that's why the name of the topic is applications of determinants and matrices. Okay. So if you remember, in the beginning of the chapter itself, I would have told you one point. If I have a linear equation like this, 2x plus 3y is equal to 7. And 3x plus 2y is equal to 5. If I have something like this. So for you to solve a linear equation, what are the minimum number of equations that are required? It purely depends on number of variables you have. If it is a linear equation in one variable, one equation is enough. Linear equation in two variables, minimum or more, maximum can be anything. If linear equation three variables, obviously you need three. Now the question is, you are able to see an equation which is a combination of constants and variables, right? How do you represent those constants and variables with the help of matrix multiplication? So matrix multiplication tells you that you will multiply the rows with the corresponding elements in the columns and add them. Is that right? So if that is the case, can I take the first matrix to be matrix made up of the numbers? So can I write it as 2, 3 and 3, 2? And I'll represent the other matrix to be a column matrix, which is XY, so that if I multiply these two, so this is a 2 cross 2 matrix, and this is 2 cross 1 matrix. When I multiply these two, what will be the order of the matrix I'm going to get? I'll get a 2 cross 1 matrix, and the 2 cross 1 matrix is going to consider 7 and 5. Is it accepted? Right? So when you see, when you have a linear equation in two variables, what are you actually able to frame with the coefficients? Right? Can I call the first matrix as the coefficient matrix? So with the coefficients, aren't you able to frame a square matrix of order 2? Right? And with the variables, you are able to frame a column matrix. So column matrix will be 2 cross 1 or 3 cross 1, depending on the number of variables you have. If you had 3 variables, then you would have written x, y, z, number 3 cross 1. So the first number is decided by number of variables you have in that particular system of equations. Then this will also form what matrix? A 2 cross 1 matrix, depending on how many equations you have. Am I clear to this point? Right? Now what I will do is, I will give a name to the square matrix as A, and I'll give a name to the variable matrix as X, and I'll give a name to the constant matrix as T. So if I write A into X is equal to T, the matrix A multiplied with the matrix variable matrix X is equal to the constant matrix. Now our job is to find what is the value of X, Y, and Z. Okay. So now you can ask me a question. Is it not easier for us to solve directly? What will you use? If at all you want to solve this, what will be the logic you use? I'll just think of elimination method. What will I do? I'll multiply this equation with 2. This equation I'll multiply with 3, so that this becomes 4x plus 6y is 14. And this will become 9x plus 6y is equal to 15. Subtract both. Minus 5x will be equal to minus 1. So x will be equal to 1 by 5. Once I get x is equal to 1 by 5, I'll substitute back. I'll get the value of y. You're going to do the same thing, find the value of x and y, except the fact that, like how you had substitution method, elimination method, cross multiplication method, you have something else called as finding using determinants, that is inverse of a matrix. That is the reason why it is given at the end of this chapter. So for that, before you do this, right, you need to know certain properties of the equations. So whenever you have 2 or 3 linear equations, right, you're asked to solve them. When you solve them, you're finding the x, y, z, right? They are called as solutions. So solution another, that value of the variables which will satisfy all the equations simultaneously. That is why they are called as simultaneous equations. Is very clear. So if at all there are equations which have either one solution or infinitely many solutions, you call that kind of you call that system of equations as a consistent system. So consistent system another equations which have the system of equations which have one solution or infinitely many solutions. So if you recollect the concept from your 10th standard, right? If I have a linear equation like this, a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. If I have these two equations, then what is the condition for them to be consistent? a1 by a2 is not equal to b1 by b2. If at all you have this kind of condition, you say the system of equation has one solution. if A1 by A2 is equal to B1 by B2 is equal to C1 by C2, you say it has infinite solutions because they both represent the same line. Then when can you say the system of equations are inconsistent? When they become parallel lines. So parallel lines, now what will happen? A1 by A2 will be equal to B1 by B2, but not equal to C1 by C2. You're able to recollect all these points. So that is what they've given it here. Okay, you can just make a note of it. Consistent means a system of equations is said to be consistent if its solution, that is one or more, exists. And when can you call it as inconsistent? If there is no solution at all. So here there is a note given. In this chapter, we are not going to be concerned about system of equations which has infinite solution because there is no point in solving it. Okay. So we will restrict ourselves to the system of linear equations which have unique solution. Means A1 by A2 will not be equal to B1 by B2. So that is the scenario. Let's get started. So why I mentioned about A1 by A2 is equal to B1 by B2 concept. You suppose the same question is asked in MCQ, right? You need not sit and waste your time in calculating the inverse at all. Look at A1 by A2 is equal to B1 by B2 or not, then you can say whether the system is consistent or inconsistent. Purida. Okay. Now, the next setting is please write it down. Solution of system of linear equations using inverse of a matrix. Solution of system of linear equations using inverse of matrix. Okay. Suppose the equations, see, first of all, what is the standard form of a linear equation in two variables or three variables? Standard form is ax plus by plus c is equal to 0. Is it right? But for you to calculate using inverse of a matrix, you need to ensure that it is of the form ax plus by is equal to c. That is the first step to be observed. Surya. Next is, if at all you have three equations like this, a1x plus b1y plus c1z is d1, and a2x plus b2y plus c2z is d2, a3x plus b3y plus c3z is d3. Then I told you first you can write a coefficient matrix. What are they? a1, b1, c1, a2, b2, c2, a3, b3, c3. You call that as capital A. Then you can write the variable matrix. Variable matrix is xyz, which is a column matrix. When you multiply these two, what will you get? You will get a constant matrix, which is D1, D2, and D3, which is also a column matrix. So how can I write the whole expression as A into X? Can I write it as B? See, some books represent with B, that is why I wrote it as capital B. So AX is equal to B means, if I take the inverse on both the sides, A inverse into X, can I write it as A inverse into B? So what is A inverse into A? So A inverse into A is I, according to the definition of it. I into X is equal to A inverse of B. Now the question is, what is the product of identity matrix and the matrix itself? It's the matrix. That is X is equal to A inverse B. So to put it in simple terms, for you to find that X, Y, Z, you need to find the inverse of the square matrix A and multiply it with the constant matrix and equate the terms on both the sides. That will be the answer. Purida. So X is equal to A inverse B. You call it as a formula or you call it as an expression, whatever you want to call it. So now you are able to understand why we are saying determinants and matrices are important. In A inverse, what do you have? What is the numerator of A inverse? Adjoint. Adjoint is a matrix. Denominator is determinant. Another application of determinant in matrices is considered under this. Okay. So X is equal to A inverse of. Shall I proceed? Right. So case 2 is, suppose if A is a singular matrix, if it is going to be singular matrix, what will happen? Determinant of A is 0. So in this case, if we calculate adjoint of A into B, okay, if adjoint of A into B, I repeated, adjoint of A into B is not equal to a 0 matrix, then the solution does not exist and the system of linear equation is said to be inconsistent. So in terms of mathematics, in terms of matrix language, if at all you have adjoint of A into B, which is not equal to a 0 matrix, then the system of linear equations are said to be inconsistent, means they do not have a solution associated with them. Okay. Suppose adjoint of A into B is equal to 0. When is this applicable? Only when? When is this applicable? Only when it is a singular matrix. Only when A is a singular matrix, you do this test. Or else what will you do? You will directly proceed with A inverse into B. Breathe up. Okay, if adjoint of A into B gives you a 0 matrix, then the system may be either consistent or inconsistent according as the system has either infinitely many solutions or no solution. So make a note of this. If adjoint of A into B is equal to 0, where 0 being the 0 matrix, then the system may be either consistent or inconsistent accordingly, you can say that the system either has infinitely many solutions or no solution. Is that point clear? Okay. Now we are ready to solve problems. It's simple. Right? So example 27, if you take, solve the system of equations 2x plus 5y is equal to 1. For example, had they given the question like this, 2x plus 5y minus 1 is equal to 0. What is the first step you need to do? Ensure that the constant is always on the right of the equal to symbol. That is the first thing you need to do. Okay. So here it is given in this way. Then you say A is 2, 5, 3, 2. B is what? XY. Sorry, not B. X. Capital X is XY. Then what is B? 1, 7. Can I say it? Then what will be the value of X? I can directly use this A inverse of B. What is A inverse? Adjoint of A divided by the determinant of A into B. First check whether the determinant is 0 or not. The determinant 0, 4 minus 15, non-zero. Now we can proceed with the adjoint method and then find it. Can you do it fast? Can you do it? Yeah. Adjoint per cofactor not in yeah. Cofactor and minus. Video could So find adjoint of A. So what is that you got? 2 minus 5 minus 3, 2 is adjoint. So don't look at the solution that there is a printing mistake. 2 minus 5 minus 3, 2 is the adjoint. Divided by what is the determinant? Determinant is minus 11. Is that right? What are the numbers? 2, 5, 3, 2. So what are the cofactor matrix? So cofactor matrix is 2, minus 3, minus 5, 2. So transpose of this is 2, minus 3, minus 5, 2. This is going to be adjoint of A. Is that right? So X is equal to 1 by det A into adjoint of A multiplied with B. So adjoint of A is 1 by det A is minus 11 into 2 minus 5 minus 3, 2 into what is the value of B? 7. 1, 7. Did anyone get the answer? Is it satisfying the equation? Did you check it? So minus 2 by 11, 5 by 11, or I can multiply both. No, I leave minus 1 by 11 as it is. So I can multiply this. No, 2 minus 35. Is it right? And minus 3 plus 14. So I get minus 33. So minus 1 by 11, minus 33 and 11. So I get 3 and minus 1. So this is xy. So x is 3, y is minus 1. Did you guys understand what it is? So first I multiply these two matrices. When I multiply, I got minus 33, 11. And outside I have minus 1 by 11. So minus 1 by 11, when it is multiplied with the terms inside, I'll get a 3 here and minus 1 at the bottom. But left hand side, the matrix is xy. So when you compare the corresponding coefficients or the corresponding terms in the matrices, x will be 3 and y will be minus 1. Now you can substitute this in the equation and check it. So if at all you want to verify whether the answer is right or wrong, use elimination method, find it out, and try to get this answer. Is there anyone facing any challenge? My video about that the class. Ram muted. So now we want you to solve 28 one. Did you get the answer? What is the answer? X is 1, Y2, Z3. Okay. So I'll just explain another method. Just observe it. You have this no. So, an alternate way of, did you all get the inverse matrix? So, what is the determinant you are getting? 7. So, determinant is 17. I'm not verifying. I hope this minus 17. Okay, correct. Okay. Now, think is, if you want to write the adjoint of the matrix, right, faster, then what you can do is take the matrix like this: 3 minus 2, 3, 2, 1 minus 1, 4 minus 3, 2. Okay. So these two columns repeat. So what are you going to do? You are going to repeat them. Repeat in the sense 3, 2, 4, minus 2, 1, minus 3. Is it clear to this? Again, these two rows you repeat it. So in the sense 3 minus 2, 3, 3 minus 2, 2, 1 minus 1, 2, 1. Okay, when you repeat them, then you can hide this row and this column. When you do this, right, start the cross multiplication from here. That is determinant. So when I find the determinant, what will I get? 2 plus 3. How much is it? Sorry, 2 minus 3. Minus 1. Okay. For this one, minus 8. No. Now, thing is, you will do this cross multiplication along the row, but you will write them vertically. Because what I'm writing now is actually adjoint. What is adjoint? Transpose of the cofactor matrix, right? So, minus 4, minus, so it is going to be minus 8. Then 2 into minus 3. Minus 6, minus 4, minus 10, write it. So do the operations along the rows, but write it along the columns. Again, start from here. Minus 3, minus 3 plus 4. No, bottom. 1, no. Okay, 1. So minus 2, minus 1. So 2 minus 3. How much is it? Minus 1. 6, 9. 3 plus 4. This is adjoint of it. Check if this is what you got. I'll repeat it, but did you understand? I'll repeat it. Kind of. So this is a way where we can write the adjoint or way faster. Because generally when you're writing the minus and so here I didn't take anything as plus or minus. I just repeated something and then took the determinant. I did the operation along the row, but I wrote it vertically. Okay. So if at all I have a matrix like this 1, 0, 2, 2, 1, 3, 3, 4, 5. Can you write the adjoint using this method? So what are you supposed to do? So those who didn't understand, look at the board. Those who understood can write on your own. So 2, 1, 3 and 3, 4, 5. What are we supposed to repeat? The first two columns should be repeated. In the sense 1, 0, 2, 1, 3, 4. Then what are we supposed to repeat? The first two rows are to be repeated. 1, 2, 0, 1, 2, 3, 1, 2, 0, 1. Then what is supposed to be hidden? Hide the first row and the first column. When you hide 2, 1, 3, 2, 1. In the intro, I repeated. See, I'll come from the beginning. See, concentrate. What is the original matrix? 102 3 4 5 so take the first two columns and repeat it in the column 1 0 1 0 adukaprom 2 1 adukaprom 3 4. Is it right? Adukaprom repeat the rows 1 0 2 1 0 2 1 3 2 1. Okay, then what you do is hide the first row and the first column. Okay, take this. So how much is it, guys? 1 into 5. So 5 minus 12 minus 7 up. So you need not think of plus or minus. Just find the determinant for everything. 3 into 3, 9 minus 10 minus 1. Gibber, this is where you need to be careful. 3 into 3, 10. So 9 minus 10 is minus 1. But you're doing the operation along the row, but you need to write the numbers along the column. So minus 7, write the minus 1 here. Okay. Then what will be the next number? 8 minus 3. That is going to be 5. Then 4 into 2, 8 minus 5. Sorry, 8 minus 0, 8. Then 5 minus 6. 5 minus 6 is minus 1. 0 minus 4. Minus 4. Then 0 minus 2. Minus 2. 0 minus 2. Then 4 minus 3 is 1. Then 1 minus 0 is 1. So this is what? Okay. But strictly don't use this in the exam. No need to be the match. Because when you wrote the same row and column again, right, you actually change their sense. That is why we never bothered about sign, because I didn't write the cofactor matrix and then bother about signs. So that is why it is called a shortcut. Right? So as I mentioned, don't use it in the board exams. If you want, you can use it for competitive exam, but if you want to find the inverses faster. Okay, but don't use it in the board exam because they'll strike it off. This method is not a part of your textbook. So whenever they ask about the inverse and you need to find the adjoint, you have to go with the standard method. Since you are able to do this in lesser time, you can do this as a verification to check whether your answer is right or not. That's when you do it at the end. End in the sense, rough work try to verify. Because you'll be sure that this is the answer. See, anyways, inverse by see, if it is only finding the inverse, this method will be helpful. If you're trying to find the solution, if the solution comes out to be wrong, you'll know where you went wrong. And x, y, z should satisfy all the three equations. No. If it is not satisfying, then there is some mistake with your adjoint or inverse, whatever it is. Okay, Anga, you can find it. But if there are problems only where you need to write the inverse of a function, that time this will save your time at that point. Purida. This is the outcome. Okay. Those who are online, I hope you could understand. You guys are there or slipped up? Are you guys there online? Okay. Listen. So the last kind of problem in this application is statement problem. So instead of giving you the equation, they'll give you the scenario. For that scenario, you need to find the equation and find the solution. Okay. So sum of three numbers is 6. Let the three numbers be x, y, z. So sum of three numbers is 6 means x plus y plus z is 6. If you multiply the third number by 3, if you multiply the third number by 3 and add the second number to it, if I add the second number to it, then we get 11. By adding the first and third numbers, we get, so by adding the first and third numbers, we get 2 times the second number, 2y. Represent it algebraically and find the numbers using matrix method. So what is the only change you need to do in this problem? In the third equation, bring the 2y to the left hand side and then proceed. So how should the third equation look like? X minus 2y plus z will be equal to 0. So now I hope you can proceed, right? So x will be equal to A inverse of B. Right, do it. Done, Nana? What is the answer? Answer. Answer. ஒழுங்கா போடு. X is equal to minus 1. 1 minus 1. X 1, Y 3. Z should be 3, correct? After that, 6 வரும். What 1, 2, 3 okay, no? 1, 2, 3. 2 plus 9, 11, correct? So 1 plus 3, 4 is equal to, correct. So X is 1, Y is 1, and Z is, sorry, X is 1, Y is 2, Z is 3. Help. MCQ. So here consistency, no other option. You need to find if they have solution. X is equal to A inverse B to find the solution. If it has a solution, it is consistent, else it is not. By looking at the equation itself, you can say. For example, what are the equations which are so first one, is it consistent? Looking at the equation, you can say 1 by 2 is equal to 2 by 3. Yes, it is. Second one, yes, it is. Third one, 1 by 2 is equal to 3 by 6 is not equal to, so it is, they are parallel lines. It is inconsistent. But you have to prove that using the inverse method. Yeah. They do it. Why are you shooting side? Do it. No? You have to, because see, for 1, 2, 3, it is fine. It's a linear equation in 2 variables. But what method do you have to say for 3 equations? There is no other option. You have to find the yes, the value of xy. So you can actually check it with the help of determinant also. First, find the determinant and see. The determinant is coming out to be 0. The case number 2 is there. No. So what did we see there? So if the determinant is coming out to be 0, then you use those 2 steps to verify the consistency. If it is not coming out to be 0, then you use the A inverse B and find the solution. Just repeat the first one. But why do you need to do that? 2 cross 2 adjoint is even more easy. I'll tell you. See, A, B, C, D, no. Adjoint is, that's it. For a 2 cross 2 matrix, one A, B, C, D is the given matrix, then just add minus sign upon the right side diagonal. That will give you the adjoint. That's it. One last problem, then we can wind up. So I hope you guys understood right now. It is all about you practicing only. There is nothing in my hands. You guys have to sit and practice. Okay. So with this, the first volume is actually over. So Monday you have a test, right? Applications of derivatives. So do one thing. Tomorrow's class will be on hold. Okay. Since there is no class tomorrow, you can sit and practice for Monday's test. Math class will that is what I'm trying to say. So practice well for the applications of derivatives. Then we'll have the next class on Tuesday. So Tuesday, what I will do is I'll do I didn't discuss the solutions for the previous test also. No. Continuity and differentiability I didn't discuss, and applications of derivatives I didn't discuss. So Tuesday and Wednesday I'll discuss the solutions for that. We will do a consolidated paper from first volume. Let's not be in a hurry to go to the second volume. You can hold integrals. You need to master this thing first, then you can go there. Then for the following week, I'll try to discuss whatever chapters you have doubts in. You guys need to let me know what are all the doubts you have. Whichever chapter needs repetition of concepts, you let me know and discuss. So yeah. So to conclude, tomorrow no class, Monday test. Next Tuesday and Wednesday there will be paper discussion for 5th and the 6th chapter tests. It's 5 to 6. Okay. That's it. We can write them. Seriya? Those are online. I hope you could hear it.
Next is only on the last exercise or the entire chapter?
Entire chapter.